Hello everyone, my name is Oza Parth and my ID number is 24CS055. I am going to explain the working of the memory, the core concept of the memory. Firstly, the types of memories. They are divided into mainly two categories. First is DRAM and second is SSDs. Both are working differently from each other and the time of work of both are also different. Now, introduction of both. First, SSD and second is DRAM. SSD, the full form of SSD is solid state drive. It stores the memory permanently. And second, DRAM. DRAM stores memory only when the computer is on. If we switch off the computer or laptop, the memory will disappear. Function. Second, we will see function. The function of SSD. It stores long-term data. It acts like a HDD, hard disk drive, but much faster than that. And function of DRAM, it stores temporary memory and used for performing active tasks. Third is technology. Technology used is NAND flash for SSD, and for DRAM we use the constant power refresh to retain data. Examples of SSD is NVMe's SSD and SATA SSDs. And the example of DRAM is DDR4, DDR5. Latest is DDR5, which is upgrade version of DDR4. Then comparison. SSD is much faster than the HDDs that are hard disk drive, and DRAM. DRAM are much faster than the SSDs, but they cannot store the data permanently. Then we are going to see how actually they works. So first, DRAM. DRAM are used for temporary processing. In further slide we will see in details how they work and at what time they come to action. Example, we are going to say example first. Opening of any web browser. For example, I open here Bing. So for opening a new tab it will take some time. See, if I'm going to open a new tab, it will take time to load and then it will open. So during this time of loading, the uh, data which are stored in permanent memory are copying to the DRAM, which is random access memory. So this time of loading are used to copy the data from permanent to volatile memory, which makes our use fast and computer fast. Second example is gaming. When we open any game like GTA 5 or Call of Duty, etc., game starts and it takes time to load. During that time, all the data which are stored in permanent memory are copied to DRAM, and we can have a smooth gameplay for that. Now, second is SSDs. SSD are used to read and write permanent data. Function stored the operating systems, applications, files, and games. Key feature faster than the HDDs but slower than the DRAMs. Now, when they are used, first to boost the computer. If we have nice SSDs, then our computer may be categorized into faster computer. And second, saving document to save permanent files, documents, etc. And loading applications like Photoshop and all the softwares are loaded. Some general examples: DRAM. DRAM are faster and temporary, used when running apps processing data in real time. Example: opening browser tab, playing games, editing videos, etc. Second, SSDs. SSDs are permanent, slower and than the DRAMs, storing files and loading operating systems. Boosting Windows, saving documents, loading games are all the tasks of the SSDs. Now we are see the brief on the CPU how it works. So our CPU performs millions of tasks per second. This is the image of a CPU in which this you can see our cooling fan which cools down our microprocessor, and this portion is the brain of CPU in which both are present STDs and DRAM. These are DRAMs and STDs. So now these are solid state drive STDs and DRAMs are this all. Now actually what happens when we load any games, at that time all the data from the solid state drive are copied to temporary memory. This when any games are started, it takes some times to load. That time are for copying the files from STD. Here you can see data are copying from here. So next slide. Now we will focus on only DRAM. STD first copies the data to DRAM. So here STD's data copy to DRAM, and then DRAM directly communicate with our CPU. So in this way all the processes are going under CPU. Now we are going to see how we can categorize our laptop into different categories, faster or slower. These are hard disk drive which can transfer 150 MB per second, and these are latest technology storage RAMs which can transfer 6600 MB per second. So you can compare both which are much faster. So on the basis of this criteria we can categorize our PC as a fast or slow. Now we will see how memory works. Memory works through a systematic process that involves storing, accessing, and retrieving data using the combination of hardware and software. So mainly we are going to discuss these three topics. First one is storage mechanism, second is addressing, and third is data flow. On basis of three topics, our memory works. So first is storage mechanism, how our memory is stored. Data is stored in binary. I am going to highlight main words. Binary means in zeros and ones form. A bit is the smallest unit of memory as we know, and a 8 bit forms 1 byte. 8 bits forms 1 bytes. Now how exactly that stores memory cells? They are stored in memory cells. Memory cells uses transistors and capacitors. Both are used for a memory cells. To store the electrical charges represent the bits. Now I'm going to show you a magnified image of the memory cell. See, this is memory cell, and each portion are looking somewhat like this. This is magnified image. This and this all chips are in these structures. Okay. Now this all sections which are highlighted are called banks. So there are 2 raised to 3 banks, 2 raised to 5 groups of banks, 2 raised to 13 bit lines, and 2 raised to 16 word lines. Now what it means? What is bit lines and word lines? Bit lines and word lines. Okay, now we are going to see bit lines and word lines. Bit lines, word lines are the horizontal lines that connect gates, terminal of memory cells, and bit lines are the vertical lines that run perpendicular to word lines. In further slide, I am going to show you the structure of both. Okay, next. So this is now if we magnify this more, this portion more, then it will look like this, in which a vertical and horizontal. As we see, horizontal and vertical are called bit lines and word lines. So this is magnified image and you can see the dimension here. Now if we magnify more, then it looks like this. This is a capacitor, this transistor, and the size are in nanometers. You can assume how uh, nanotechnology is this. See, this is capacitor. If we cut this image from between, then it will appear like this, in which this is capacitor, this transistor. Capacitor is used to store 1 and 0, and transistor only reads or write. See, capacitor holds 1 bit only. Each capacitors in this image, in back you can see this all, this also. Each of these can store only one bit. It holds 0, either 0, either 1, either 0, either 1. Both can be held by capacitor. Okay, next. Now capacitor are structured like this, in which these two lines, this and this, both are insulated, dielectric insulator, in which we can see the specification that they are their thickness is 20 to 30 atoms, and these two also are there, which then these both are conducting, this and this are conducting surface of capacitor. Now in before slides we have seen bit lines and word lines. So here I have given you magnified image, in which these are vertical and horizontal lines which represent bit lines and word lines. This is channel and this is gate used to on and off our capacitor. Now addressing a data management. Addressing and data management, this is the second point of a memory working, in which each memory cells has a unique address. If we want any particular file to be displayed on our display, then microprocessor send particular address to our chip, and which takes the chip to this address and grab all the data from that address and display to our computer. CPU use address buses to locate the specific memory. Now what is a data bus? What is data bus? Control buses regulate the read and write operation. Now we are going to see what is data bus. Data bus. Data bus is a communication pathway that transfer data from different component of the computer, particularly between the CPU, memory, and the hardware device, storage drive, graphics card, etc. Means it used for transferring data from one point to another point. In that purpose, we use data bus. And data bus, address control bus, these all are the buses which together works. Finally, in conclusion, memory play a crucial role in functioning and efficient of modern computing. From the rapid access of a primary memory to the extensive storage capabilities of a secondary and tertiary memory, each type of memory serves a specific purpose in ensuring smooth operations. Understanding how memory works is a hierarchical structure, and advancement in storage technology helps to appreciate the seamless experience we enjoy while using digital devices. Thank you.